So we are supposed to show that the points, suppose let's call this A, let's call this B, and this is C, are collinear. So if we can prove that B divides A and C in some specific ratio, then we can also say that the 3 points are collinear. We just have to find that ratio and we have to prove that it remains consistent. So it's not just for B, we can prove that A divides BC in some ratio. The ratio could be internal or external, so it doesn't matter. So now A point is A minus 2B plus 3C, and C point is minus 7B plus 10C. Now suppose B divides A and B in the ratio lambda is to 1, then by section formula we can find out the vector of the point which will divide AC in this ratio lambda is to 1. So it will become minus 7B lambda plus 10 lambda C plus A minus 2B plus 3C upon, we know the section formula, it will be lambda plus 1. And now we have to check if this is equal to the point B. So that is 2A plus 3B minus 4C. Now if ABC are non-collinear, then we will have to equate the coefficients of ABC individually. So let's see. Over here we are getting, for A there is only one term and the coefficient is 1. So 1 upon lambda plus 1 is equal to 2A, is equal to 2, only 2. So from here we are getting 1 equal to 2 lambda plus 2, and lambda is equal to minus 1 by 2. Now if we get lambda as minus 1 by 2 for the B and C vectors as well, then our proof will be complete, because then lambda is to 1 will be the ratio at which B divides AC. So the ratio remains consistent, right? That's why we can say that A and C are collinear. So now let's check for point B. So we get point B, vector B from here and here. So that is minus 7 lambda minus 2 is equal to 3 into lambda plus 1. So 3 lambda plus 3. Now this is 10. So minus 10 lambda is equal to 5. So lambda is equal to minus half. So yeah, we are getting lambda is minus half again. Let's check for 3 as well, C as well. So for C we are getting it from here and here. So 10 lambda plus 3C is equal to minus 4 lambda minus 4. So this is 14 lambda is equal to minus 7. So lambda is equal to minus half. We are getting it again. So lambda is consistent. So the points ABC are collinear. Now let's move on to the next part, part B. So for part B, we have to do the same thing again, but over here instead of the vector, they have given us the coordinates of A, B and C. And we have to prove that they are collinear, and we have to find out the ratio in which B divides AC. So we have to do the exact same thing that we did in the previous sum. So suppose A and B, A and C, let's assume A and C, they are dividing, B is dividing AC in the ratio lambda is to 1, and if we get a consistent value of lambda for all three equations, then the collinearity is also proved and we will also find our ratio. So we know how to use section formula. It is C into lambda and A into 1. So the coordinates of that point will be minus 3 lambda plus 1 upon lambda plus 1, comma, minus 2 lambda plus 2 upon lambda plus 1, minus 5 lambda plus 3 upon lambda plus 1. And this we have to check if this is equal to 3, 4, 7. Now let's equate the x coordinate. So minus 3 lambda plus 1 is equal to 3 lambda plus 3. So this will become minus 6 lambda is equal to 2 is equal to 2. So lambda is equal to minus 1 by 3. Let's check for y. Minus 2 lambda plus 2 is equal to 4 lambda plus 4. So 6 lambda minus 6 lambda is equal to 2. So again we are getting minus 1 by 3. And minus 5 lambda plus 3 is equal to 7 lambda plus 7. So 12 lambda is equal to 7 minus 3. This is minus 12. 7 minus 3 is 4. So lambda is again equal to minus 1 by 3. So the collinearity is proved and the ratio is minus 1 by 3 to 1. So that is basically 1 is to minus 3. So that is 1 is to 3 externally. So our answer is complete.